Imagine you're looking at a map of the United States, and suddenly you realize that everything between New York and Los Angeles is just missing. No cities, no roads, no mountains, just a flat, silent void. That is essentially what happened to astronomer Robert Kirshner in 1981. Kirshner and his team were mapping the geography of the universe, plotting where galaxies live in the night sky when they hit a dead zone in the constellation Boötes. This wasn't just the usual empty space between stars. This was a sphere of nothingness, 330 million light-years wide. To put that scale into perspective, if our Milky Way galaxy were the size of a single quarter, the Boötes Void would be a hollow bubble over 8 feet wide, containing almost nothing. When the data came in, it didn't make sense. The universe is supposed to be like a cosmic web, strands of galaxies connected by gravity with small gaps in between. But the Boötes Void isn't a gap, it's an abyss. According to standard cosmology, creating a void this large should be extraordinarily unlikely, the kind of structure that appears only at the extreme edges of probability. Kirshner's team, working out of the Harvard-Smithsonian Center for Astrophysics, found that where there should have been thousands of galaxies, there were only about 60. And they weren't just floating randomly, they were hugging the edges, like they were afraid to go into the center. Kirshner called it a major structural feature of the universe, which is the polite scientific way of saying we found a hole in reality and we have no idea why it's there. Naturally, the theories started flying. Was it a merger of smaller voids? A relic from the chaotic first moments of the Big Bang? Every explanation pushed known physics to its limits. It didn't fit the pattern. It didn't fit the timeline. It was just empty. Astronomer Greg Aldering spent years in the 1990s confirming the void's boundaries, measuring its dimensions, verifying that yes, this thing is exactly as big and exactly as empty as it appears. The more precisely we mapped it, the stranger it became. The void's shape is almost perfectly spherical, too regular, too geometric for something that should have formed through random cosmic processes. And here's what keeps cosmologists up at night. The Boötes Void isn't alone. Since Kirshner's discovery, we've found other supervoids scattered throughout the observable universe, each one a scar in the cosmic web, each one a region where our expectations seem to fail. But the Boötes Void isn't just empty space, it's a wound. And as we would discover decades later, it left a fingerprint on the universe that goes back to the very beginning of time. A ghostly signature written in the oldest light in existence. Investigations like this don't come from shortcuts. They come from slow research, verified sources, and human judgment in a world flooded with instant AI content. If that commitment to the truth resonates with you, subscribe and join the Dimension. It's the only way we keep these investigations independent. Now, let's talk about what happened in 2004 when we finally saw that ancient fingerprint. In 2004, NASA's Wilkinson Microwave Anisotropy Probe picked up something that made the Boötes Void infinitely more disturbing. The satellite was measuring the cosmic microwave background, the faint afterglow of the Big Bang itself, light that's been traveling through space for 13.8 billion years. And when astronomers looked at the region of sky where the Boötes Void sits, they found something wrong with that ancient light. It was colder than it should be. Here's why that matters. Think of the void like a massive valley carved into the landscape of space. When a particle of light enters the void, it falls down into that valley, picking up energy as it descends. Then, as it climbs back out the other side, it should lose that same energy climbing back up. If the universe were standing still, the light would climb out with the exact same energy it had going in. No harm, no foul. But the universe isn't standing still. It's expanding. And while that photon is crossing the void, a journey that takes hundreds of millions of years, the void itself is stretching, becoming deeper. So when the light tries to climb back out, the hill is steeper than when it fell in. It has to work harder. It loses more energy than it gained. By the time it reaches our telescopes, it's exhausted, measurably colder than the light around it. Physicists call this the integrated Sachs-Wolf effect. It's real physics, well understood, completely expected. Except the temperature drop observed in the Boötes region was larger than the models predicted it should be. The void was leaving a deeper imprint on this ancient light than standard cosmology could easily explain. But here's where it gets truly unsettling. This doesn't mean the void existed in its current form when the universe was only 380,000 years past the Big Bang, but it does mean that large-scale structures like this evolved in a way that left measurable fingerprints on the oldest light in the universe. Somehow, the seeds of this emptiness were already there, woven into the fabric of space-time when the cosmos was still in its infancy. So what carved this hole? What cleared out a region 330 million light-years across and left behind a structure that defies our predictions? When the Sloan Digital Sky Survey mapped the void in 3 dimensions during the 2000s, they confirmed what earlier observations suggested. The void's shape is remarkably spherical for a structure formed by chaotic processes. Natural voids in the cosmic web are messy, irregular, squeezed by surrounding structure. The Boötes void sits there like an almost perfect bubble, its boundaries clean, its geometry precise. That kind of regularity doesn't emerge from chaos. It suggests organization, structure, something that acted uniformly across an incomprehensible volume of space. Scientists proposed increasingly exotic explanations: quantum fluctuations amplified to cosmic scales, variations in dark energy, gravitational influences from beyond our observable universe. But every theory felt incomplete. And then we discovered that the mystery was about to get worse, because the void isn't just sitting there, it's growing. Between the surveys of the 1980s and the comprehensive mapping of the 2010s, astronomers noticed something that turned the Boötes Void from a cosmic curiosity into a genuine crisis in cosmology. The void appears to be growing, not by adding matter, but as surrounding galaxies drift away and the cosmic web stretches around it, as if the emptiness itself is contagious. This is where our understanding of the universe starts to break down completely. The Lambda-CDM model is the standard model of cosmology. It's the framework that describes how the universe evolved from the Big Bang to today. It successfully predicted the cosmic microwave background structure, the distribution of galaxies, the formation of cosmic filaments. It works. Except when it comes to the Boötes Void, it doesn't. Multiple research teams have run simulations adjusting every parameter they can think of: dark matter density, dark energy properties, initial conditions from the early universe. They're searching for any combination of known physics that can reproduce what we observe. And the simulations do produce cosmic webs with voids in them, yes, but nothing approaching the scale and characteristics of the Boötes Void. The few simulation runs that manage to create supervoids this large require such specific, finely tuned starting conditions that the probability becomes absurd. We're talking about cosmic lottery odds so extreme they border on meaningless. And even those rare, successful runs fail to match the void's other properties: the spherical shape, the distribution of those 60 internal galaxies, the magnitude of the cold spot in the cosmic microwave background. This isn't a small discrepancy. This is a 330 million light-year wide problem. What makes this failure even more disturbing is that the Boötes Void isn't some distant, poorly studied anomaly. We have decades of data from multiple independent surveys, measurements from different types of telescopes observing different wavelengths, large-scale structure surveys, redshift maps, background radiation studies. Every line of evidence points to the same impossible conclusion. The void is real. It is exactly as large and empty as it appears, and we have no adequate explanation for how it formed. Some cosmologists have started whispering about physics beyond our current models. Maybe dark energy doesn't behave uniformly across cosmic distances. Maybe there are interactions between dark matter and dark energy we haven't discovered yet. Maybe the fundamental properties of space-time only reveal themselves at these incomprehensible scales. But let's be honest about what those words actually mean. They're not explanations, they're admissions of ignorance dressed in technical language. We're essentially saying something unknown created this, and that something involves physics we don't understand. The Boötes Void sits there, 700 million light-years from Earth, expanding with the universe, carrying its ghostly signature in the ancient light of creation. It holds its 60 galaxies in a space that should contain 2,000. It violates our models. It defies our simulations. It challenges everything we thought we understood about how the cosmos works. And it's not alone. We've found others. The universe, it turns out, is full of wounds. For a species that likes to believe the cosmos is orderly and predictable, the Boötes Void is a reminder that we may be living inside a structure we barely understand. And the scary part isn't that these wounds exist, it's that we don't know if they're finished growing.